So let me talk about what turning points are. The turning points in a graph. It indicates where the graph of a function changes from increasing to decreasing. And I'm putting this like double arrow here so you understand that it's increasing to decreasing or decreasing to increasing. Either way, it's just, so indicates where the graph of a function changes from increasing to decreasing. That's what a turning point is. And here's a little side definition for you. A polynomial of degree n, so we talked about what it means to be a degree polynomial yesterday. So a polynomial of degree n has at most, underline that, at most, n minus 1 turning points. A polynomial of degree n has at most n minus 1 turning points. So let's think about this. If I am a degree 3, one of the disco graphs, what's the most turning points that I could have? 2. Okay? I could go up, down, up, like that. That would be 2 turning points. But I could also have, the most I could have would be 2. That means I could still have 1 or 0. Okay? So let me just give you an example here of a degree 4. Like we saw what degree 4 looks like yesterday. Here's 2 pictures of a degree 4. Here's one, the upside down M. But here's another one. Degree 4 can almost look parabolic. It really could, it actually does. It falls into that one. How many turning points does this one have? 3. Goes right here. I call it the bumps. That's what I look at. The bumps is really where the turning point is. Here's 1, here's 2, here's 3. 3 turning points. And that falls into play because the most it can have would be 4 minus 1, which would be 3. This is a very easy question to get right on like ACTs or SATs. How many turning points does the function, whatever, x to the 8th, whatever? I mean, what's the most it could have? And you'd just be like, oh, degree 8, 8 minus 1, 7. I mean, it's really easy question, but you got to remember it. This one has only 1 turning point. It's still a degree 4. Doesn't mean it has to have 3. It could have 3, it could have 2, it could have 1. The most it could have would be 3. All right, so how does this all play out together? So here's what you'll do. Example 1, and it's a long directions, but this is what the directions on the homework will say tonight. State the number of real zeros. So you don't need to worry about roots are. You should know how to find them. You should know how this graph goes in terms of end behavior, how many turning points. You should know what this looks like now without a calculator. You don't need a calculator anymore. You should know what this looks like. So let me kind of help you out here and lead you with what I would say this is what you should do for homework tonight. First thing I look at is what's the degree of this polynomial? 3, okay? That's going to tell me a lot. First of all, that helps me find out how many turning points it could have, the most turning points it could have. What is the most it could have? 2. 3 minus 1, 2. Okay? So the most it could have is 2. Now, if you remember back when we talked about end behavior, and I do want you to write down end behavior because I think a lot of people forget this step, and it's really important. All even degree polynomials are either going to be parabolic and start up and end up, or they're going to start down and end down. Remember doing this, right? Okay? And how do I know if it's up, up, or if it's down, down? If this is positive or negative, if the coefficient in front is positive or negative. If it's an odd degree, all odd degrees look similar to or have end behaviors like the cubic one. Okay? This is an odd degree. It's positive odd degree, so it's going to start down and it's going to end up. It's going to have at most 2 turning points, and I'm going to find out where those zeros are right now. And how do I find those zeros? I find them by factoring. All right, so what can we factor out of this? Let's see. An x, right? X squared minus 5x plus 6. And then what does that factor into? Minus 3 minus 2. Set it equal to 0. Where are all my real zeros right now? 3 and 2 and 0. Okay, don't forget that x in the front. So then when you go to sketch this graph, here's what I want from you. Again, I don't want you can check it in the calculator, but I don't want you to use the calculator. You won't be able to on the quiz. So you will then make a graph. You'll go to your zeros, 0, 2, and then 3, okay? I know it's a degree 3, so I know it's gonna have like start right here, my end behavior, I start on the bottom. I'm gonna end up, start down, end up. And then at these zeros, it's gonna cross through, so I'm gonna cross through at 0, cross through at 2, and then cross back up through, and of course I put my thing over here. That looks terrible, but it's just sketching it. I'm not looking for complete accuracy. Start down, cross through, cross through, cross through. I have 2 turning points. I'm a degree 3. This is a perfectly fine sketch for me right now. How could I find those max and mins? I mean, obviously you could find the max and mins if you want to on the calculator. You could find the y-intercepts, all those fun things. Well, the y-intercept was 0, 0. But you have known so much right now from just this picture here. It shows me how much you know. You know domain, you know range. I mean, all that stuff. It's brilliant. Do you not feel brilliant?
No.
Why? All right. Today. So what could you tell me about this graph right now? Anything?
Domain, range.
You can tell me domain to range. Do you know the degree?
Mm-hmm.
What's the degree of this one?
3.
Why is it 3?
Because it's 2 turns.
It has 2 turning points. Okay? 1, 2. So if we work backwards,
Wouldn't it be like
it could. But we're on the track of this could be a degree 3. We know the end behavior. Look, it starts down, ends up. So it's definitely an odd degree. We know that for sure. It's got 2 turning points. Now, yesterday, these zeros were important, right? What is this 0 right here? -2. And what's this 0 right here? Positive 3. So remember, if we were writing an equation, we go like that, and we'd write x minus -2 and then x minus 3, right? But if I FOILed this out, I would get a degree what? 2. I FOIL this out, I get x squared minus x minus 6. So how do I get degree 3 out of this? Well, here's the thing, and this is what we're going to find out. When you touch the graph, you have an even multiplicity. Well, what does that mean? That means this factor right here must be at an even power. Right now it's at an odd power. It's at 1. It must be probably at 2 or 4 or 6. If it crosses through like this one did, then it has an odd power. I'm going to call it 1. What's 2 plus 1 make? 3. If you punch this in your calculator right now, this is what you're going to say. So this is the definition for what we call multiplicity. If you have a 0 or a factor x minus c to an m power, whatever that m happens to be, if it's an even number or an odd number, whatever it happens to be, there's 2 rules, okay? If a 0, c, if that 0 right there has odd multiplicity, then the graph crosses the x-axis at x equals c. So if that power right there is a 3 or a 1, usually you don't see ones, but just so you know, if it's a 1 or a 3 or a 5 or a 7, it's going to cross through the x-axis. If, however, the 0C has even multiplicity, there's a lot of I's in there, then the graph is tangent. Now, what does tangent mean? Tangent means it just touches. It just touches at x equals c. If it's odd, it's going to cross right through. If it's even, it's going to touch. So we're actually going to do 2 of your homework problems right now. Because I am a kind person. Unfortunately, I won't be able to do this on my lovely picture here.